The following content has been provided by RWTH Aachen University.
All right, good morning, everybody, and welcome to Designing Interactive Systems 1. Before we dive into today's topic, evaluation, we'll do a quick review of what we talked about last time, which was prototyping. First question, if you have an idea, let's hear about a couple of different paper prototypes. Anybody remember any paper prototypes that we built?
I remember there was something like a screen where we put post-its on. I don't remember the exact name, but yes, that's what I remember.
Okay, yeah, that's the post-it prototype. Very complicated name for that one. And you're right, that's one of the paper prototyping styles. It's actually one of the more complex ones. We said that's the one that you can actually get a bit more flexible about. We started with storyboards and flipboards first, right? The storyboards really looking like a comic, basically, and flipboards being one screen on one page that you can flip through like a flip book. All right, so then we had software prototypes. We looked at a couple of different kinds of software prototypes. Again, anybody want to share one that you remember from the kinds of software prototypes, or we could also call them digital prototypes that we talked about?
We talked about the PowerPoint prototype, I think.
Yeah, that's right. Mm-hmm. And was that more on the what was different on that compared to like a paper prototype? What can you do with a PowerPoint prototype that you can't do on paper?
It was more interactive. Like people could click on buttons, for example, and it would like switch the slide, I guess, to like the result.
Exactly.
Yeah,
that's right. So the big thing about those software prototypes, of course, is that they can be more nonlinear and they can actually contain the logic for driving your prototype. You don't have to be doing that yourself anymore as you have to with a paper prototype, obviously, because paper is kind of dumb, but just sitting there. We went all the way from simple screenshot prototypes that you can still click through. You can still have a linear prototype, right? That just rolls out click by click, or you can have one, as Gabriel was just saying, where you have some branching opportunities to follow different kinds of interaction pathways through your prototype. And then we identified two ways of limiting prototypes, a horizontal one and a vertical one. So anyone feels like taking a stab at what the difference between those two is? Difference between a horizontal and a vertical prototype? Yeah, Hua, go ahead.
Yeah, I believe for the vertical prototype, and there is not so many functions, but every function is detailed. And in contrast, the horizontal prototype has the entire UI functions, but not so detailed.
Yeah, that's right. Very good. Thank you, Haiwa. By the way, you might want to check at some point. You're coming in a little hot and your microphone is little high levels. But we understood you very fine, so don't worry. All right, yeah, that's the thing. Excellent. And so then we will move on to some of the tools we talked about. Gabriel also already mentioned PowerPoint. What other things did we talk about? We looked at a lot of different tools for software prototyping. You can't just do that with PowerPoint. Any others yet you might remember? Any other software tools that you can use to build prototypes, UI prototypes? Yeah, Eric, go ahead.
We talked about prototyping tools like Adobe XD, which can they are wireframing tools. Sorry, completely switched that, which can be helpful if you would like to create wireframes. And we talked about web development, which could be an easy way to build a UI prototype. Give a feeling to the user.
Exactly, especially if your final system is actually going to be on the web anyway. And Ollie gave a nice demo for doing that. Yeah, and we also had some special purpose tools like MaxMSP for multimedia, or even the user interface builders that are built into your typical IDE that you're using, like in Visual Basic or in Xcode. And then we talked about hardware prototypes. So what would be a reason to consider doing a hardware prototype? Why would you do that? Oh, I get to pick again. I get to pick. Kim Vinnemöller, how about you? Why would I do a hardware prototype?
I'm not sure if it's right, but one reason I'm thinking of is that you want the user to have something to really play around with, and
yeah, I mean that's part of the reason. Let's see here. I think oh, I saw Ben has his hand up too. Go ahead.
Yeah, I think a hardware prototype is different from other prototypes, as in it's about the haptics of a product or an object where you want to hold something in your hand. I think the example you gave was prototyping mice. For example, if Microsoft or Logitech or someone, they want to build a new keyboard or a new mouse. Of course, they can show off the software and pushing the buttons and what it does, but that's like boring. That's always the same. You actually want to know, how does the mouse feel in your hand? And they had like styrofoam cutouts, if I remember correctly. So they could prototype and model them quickly, and you could quickly have a prototype that can have in your hand and feel how it feels and whether it's like good for the palm of your hand and stuff.
Exactly. Good. Great. Thank you, Ben. And as an sort of variant of the hardware prototype, or as a variant of prototyping in general, we talked about the Wizard of Oz technique. Now that's an awesome name for a technique. Does anybody remember how it works? Felix, go ahead.
Yes, it was like someone is sitting in the background. Sometimes it's visible, but often it's not. And he's like playing the response of the system. So when someone is interacting, he moves the things around in the software according to the algorithm would do if the software would be finished.
Exactly. Yeah. So especially if there's something that's really difficult and really expensive to implement at this point, or maybe even near impossible, you can just fake it with a person simulating the UI. Excellent. All right. So now on to evaluation for today. We're going to talk about when you evaluate, where you do this, why you do it in the first place, and what we evaluate. And then we will go through a little bit of a decision tree, if you want, of concrete methods to evaluate designs and implementations, basically your prototypes in a variety of different ways. And there'll be a little bit about how to work with users, with testers who are trying out your systems and helping you debug them. First of all, when do we evaluate? Here's the DIA cycle again. And we're obviously in the analyze stage, right? That's the one where evaluation takes place. So that's pretty obvious. But since it's a cycle, that means it happens not just once. In fact, evaluation should happen throughout the entire software development process. This is one of the key things where it's like, you're shooting a rocket at the moon. And if you only take your aim at the very beginning and you never correct your course, you're going to miss the moon 100%, right? You're never going to hit it. So you need to continue doing course corrections to keep your target in sight. And that's what you're doing with your evaluation. Every time you correct, you get back on track and get where you want to be. So it happens a lot. Early designs, like the paper prototypes, for example, that we talked about, are often evaluated informally, maybe even inside the design team without involving external users at first, and often more in a form of an analysis. You look at it hard and you take your ideas and results from that. Later implementations, where you get to like software prototypes that begin to feel like the final system, maybe even, tend to be more often evaluated with users, and often in larger sort of experiment-like settings, user studies. And these are often also done a little bit more formally, where you really have a process laid out, how you do it, and get results based on a particular protocol. So I know we're all smart. So it's very likely that you think you've made some smart decisions for your design, but I promise you, you will be surprised by hearing what people are going to do or say or give you as feedback about your prototype, or even what they just, how they handle it. There's often a big mismatch in our own mental model of how we think the problem should be solved in a prototype and how our users will perceive it. And that's why you need to do this. You need to have the reality check of others looking at your software and at your design. So even if you have an amazing design team, if you don't get feedback from outside the team, from your user base at some point, that can lead to terrible products. So we evaluate, well, first of all, to just make sure that our system matches the needs of our users, right? And you might say, oh, well, but I already did interviews. I already talked to my users. I have my, my requirement specification. I've asked them what they want. I don't need to talk to them anymore. It doesn't work that way. Remember the course corrections of that rocket firing for the moon. You need to make sure that you continue to evolve users, because even the users at the beginning of the process don't know exactly what they want. How should they, right? They're no smarter in the design than you are. So you need to continue doing evaluations and oftentimes involving end users in your evaluation. So what are we doing? Well, we're trying to judge a couple things. First of all, you've found a couple features that you decided to put into your system, right? Based on your initial design ideas, initial interviews maybe with users. Now you need to find out, did I actually collect the right, number of features and the right bundle of things to do? And that's something that your users will be able to tell you. Are the right features, at the front of the UI easy to reach? Have I pushed the right ones back into, dialogues, option dialogues or something, or menu options? Are they presented in general as expected? Does the interface look like something that a user will find their way around if they know the domain? If you're doing a design for a mobile banking app, do people find themselves at home that have only been doing banking on the desktop so far? Then you want to actually understand the effect that your interface has on users, right? So you want to look closely and try to judge how easy is it to learn the system and use it. These are two different things. You can have systems that are difficult to learn, but once I've mastered them, I can be very effective with them, which is great if you have expert users using it, 8 hours a day. Or you can have systems that are easy to pick up, but are therefore a little less efficient in their day-to-day use, which can be fine for occasional users too. And you also want to get a couple of more subtle cues. You want to actually find out whether users, while they're using your system, get frustrated or get lost or get confused. Are there things that basically are overloading them with information or choices or just options or complexity? And in general, you want to get a feel for what people are thinking of your user interface. And then you are also looking for specific issues. Are there any unexpected situations coming up, unexpected or confusing situations coming up? Those are the most interesting ones. And you will always find these. When you have users evaluate your prototype, they will find lots of mistakes that you made and that are possible to make. And then they will do things with your prototype that you would have never expected to happen, right? They will also find the impossible problems that you never thought existed. There's the famous story of the guy who works at the hotline for a computer company, and user calls in and says, I'm unable to install that software from the second DVD. And after long back and forth, it turns out that user didn't know that he had to remove the first DVD from the drive before putting the second one in. Now that seems completely ridiculous to us who are very computer savvy, but hey, somebody forgot to mention that. And if you have somebody who's first time installing a software with their DVD drive, then they need to be told those kinds of things. All right. Now, where can we do evaluations? We got basically two options. We can evaluate inside a usability lab. Like, this is a picture of a lab. Now, of course, these days you wouldn't have you know, CRT monitors there, but the principle is important. You have, back in the image here, we see a user sitting in front of a computer working on, you know, a prototype. And in the front here, we have the person watching them. You know, on the one hand, having multiple camera views of the user being recorded, off the screen, maybe even of their hands on the keyboard, so that, you know, with the top camera facing down, and taking notes on a laptop in addition to make notes of anything that they might notice. This is a high-end, full-blown setup, having even, you know, the Venetian glass sort of mirror wall in between where the you know, the experimenter can see the test person, but the test person cannot see the experimenter, kind of like in, you know, CSI Miami. And this is great because you've got all this equipment there, right? That you don't normally have available when users are just at their normal workplace. And you have no disruptions, right? This is a lab situation that you control. So it's quiet. But that is also the problem with the lab studies. You need to be aware that this is an unnatural situation, right? You are missing the user's missing the usual, whatever, you know, bookshelves that where they pull, you know, a reference manual from, or the wall calendar hanging on the wall that they casually glance up to and find out what, you know, day of the week a certain date is without having to use their computer at all. So it is not the natural environment that the user is normally working in. And that also creates a certain unnatural situation for them, right? They are not surrounded by their colleagues. They might feel uncomfortable because they feel like it's a test environment. And so you may be observing things and you can observe them very clearly and measure them very finely, but it's not 100% sure whether what you're seeing is actually going to happen in the same way in the real world. This is something you need to just keep in mind when you do these lab studies, and then they're perfectly fine, right? So it depends on whether, you know, certain situations. For example, if the real location that the software needs to be used in would be actually dangerous for you to enter and work in, you may, for example, not be able to run, you know, elaborate user tests and install lots of additional technology in a nuclear power plant control room, right? So there you may need to take people into the lab to run studies. Or maybe it's just really far away. International Space Station comes to mind, right? You know, and can't really run studies up there. So you may need to do it in the lab. Or sometimes you need a controlled situation. For example, if you want to figure out, you know, is it faster to use a circular menu than a linear menu to select things, and you want to really measure things down to the millisecond, then you don't want any distractions. You really want, you know, raw performance of users to just make that decision. Okay, now the option, of course, is not to go to the lab, but go to the field, right? So you can go to the user's workplace and run a study there. And that is basically in the user's natural environment, right? Workplace or even at home, whatever it is. First of all, this is, of course, more realistic, right? In part because of the disruptions, right? The phone ringing and a colleague calling while somebody's half done typing in something in an interface, that's actually going to happen in the job. So you would miss that in the lab because those disruptions don't happen there. The situations therefore become more natural to the user, and their behavior will be a little bit more natural too. It is also a better suited environment for long-term studies. If you want to study the effect of a software for weeks or months, it's really hard to pull people for weeks or months out of the workplace and work with them in a lab setting or continue having them come to the lab for this. It's much more likely that they can integrate this into their daily work practice when they are at their job. Now, of course, the noise and task interruptions can also be detrimental to what you can measure and how precisely you can measure things. And while it is a more natural environment and people will be a little bit more relaxed because they will feel more competent and at home where they are literally, it will still feel like a test situation. So that doesn't fully go away. We will talk about how you can help people feel more relaxed and feel less like they are being tested, because they're not, right? You're not testing them, you're testing the system. We'll talk about this at the end of this class. And finally, I should say, you can also run, there are examples for long-term studies in the lab. The MIT, for example, and many other places have living labs. That's a big thing these days. You know, they have a research house for the elderly where people might live for weeks at a time, you know, with sensor-equipped rooms, and then you can really track daily patterns and build software that helps these people. Now, an extreme case of, I said earlier, it's hard to pull somebody from their workplace into, you know, basically being your test study subject for weeks or months. There's an extreme version of this where the user actually becomes part of the design team. And that approach is called participatory design. What that means is you get a user to become part of your design team during the entire software design process. This started in Scandinavia, where it is actually the law for certain products that you need to involve people in this kind of way. Right? If you bring software into the workplace in government institutions, for example, you need to bring people from the actual domain that will end up using this software. You need to bring them in and have them be part of the design team. And that's what, by the way, we're doing at RWTH right now. We're talking to central administration folks who are rolling out new software that university staff and students will be using. And we're making sure that we get these end users involved in the process. But somewhere it is actually a law. Now, for this, of course, you need lots of good techniques for communication in teams. We've already talked about brainstorming, storyboarding. But you know, paper prototypes can be good tools because now you have people in the team who have no original clue of either interface design or the engineering behind building software, right? And that's not their domain, and that's not why they are there. They're experts from the actual application domain. They will be the ones who will be using your software in the end. And so you need good team communication skills for this that work well across these disciplines. Some of the challenges of participatory design, although the payback can be immense, right? Having this kind of situation is, first of all, of course, it's a lot of effort, right? You know, pulling somebody out of their productive work for these kinds of meetings again and again is of course a cost question. A second, more subtle problem could be, let's say we're developing software. We're actually doing this right now. We're developing software for the purchasing processes at the university, right? And so we're going to say, well, you know, the people who are often doing the purchasing are the administrators, the secretaries, you know, at each lab. Now that's right. So we should bring them in and hear what they have to say. But maybe there are some faculty colleagues who want the process to be done differently. So now all of a sudden we're giving the secretaries, administrators, a more powerful role in this design process than their bosses, basically, you see. So this can often lead to these, you know, conflicts with the hierarchies that are in place at your client, right? At the company that you're designing for, that you're selling your software to. And then finally, there's a weird effect that's called user conversion. You may know about the Stockholm syndrome, right? Somebody who was a hostage for a long time started to actually sympathize with the criminals they're holding the person hostage. And something similar can happen when you make somebody part of your design team. After a while, they begin to pick up the design lingo, the design way of thinking, which is great, but it can also mean that they start forgetting what it is like to encounter the software as a user who doesn't know all this stuff, right? So in a way, you may ruin that user after a while for giving you an unblocked natural view of the system from an end user's point of view. Just be aware of that. They might feel more like a part of the design team than an end user after a while. All right, so now we get to the little tree I was promising you. The first decision you need to make is, do I involve users or not? You do not always, and sometimes you cannot, involve users in your design. If you cannot do that or do not want to do that because of a variety of reasons, maybe, you know, it's too expensive, or maybe you have just a small question that you think it's a decision that is should be so obvious that you think you can get some feedback out of your design team, or you are doing a preliminary weeding out of options before you show the best candidates to the users. Or maybe you don't want to share your idea yet with the broader market, then you need to evaluate without users. And there's a bunch of techniques that we'll go into today. Literature review, cognitive walkthrough, heuristic evaluation, and model-based evaluation. We'll actually do that last part mostly in a separate lecture because it's a little bit of a bigger topic. And then we have evaluating with users, the one that I mostly was alluding to earlier here when I mentioned things like participatory design and all these things, and lab and field studies. So these can be qualitative or quantitative. The qualitative ones are things like model extraction, silent observation, think aloud, constructive interaction, or retrospective testing. And we've got quantitative techniques. And under those, we count everything that we consider controlled experiments. The differentiation of qualitative versus quantitative basically means with quantitative, you get numbers. For example, you can find out whether one option to arrange a menu items is faster than the other one. So that gives you a number, but it doesn't tell you why, right? So for finding out why that one performed faster than the other one, it's helpful to use a qualitative method of study where you look at people, observe them, maybe interview them, talk to them, and find out, okay, why did that happen? So both are important mechanisms. None is better than the other. We tend to think that quantitative methods are better because we're engineer trained, but they're not really. In fact, some questions you will never get answered with a quantitative study. For those, you need to do qualitative work as well. As I said earlier, remember the techniques evaluation without users tend to happen earlier in the process and the more informal stages of evaluation, and the evaluating with users tends to happen later in the process with more advanced prototypes more, although it doesn't mean that you wouldn't be involving users even from day one in your project. And of course, all this can be banked and supported by interviews, questionnaires, etc. And for example, for an interview, you don't even need a prototype, right? You can do that really early on to find out, to do what people sometimes call user discovery, right? And understanding who your users are and what they might need. All right, let's look at the first one. This one should be feeling comfortable to you because it's what you're used to as doing as studies, as students. A lot of research results about UI design have already been published. So if you're wondering, should I use a pie menu or a linear menu for this, for this office task application? Take a look at the literature that has probably been studied, and you can probably find pretty good models that explain to you when, under which circumstances, pie menus are faster than linear menus. Like pie menus being these circular menus where things are arranged in pie-shaped parts of a circle around your mouse cursor. So you search the literature looking for arguments for your design or maybe against it, right? And this can often save you a lot of time running your own experiments, right? But it means overcoming that hurdle of, yes, I need to go online, go to the digital library, or maybe even visit a physical library occasionally. There's the wonderful saying that among researchers that says, a lot of students think that spending a few weeks in the lab can save them a whole afternoon in the library. Got to think about that for a minute, then you will understand the irony of it, because that is often the case. You can spend a lot of time doing a lab study, and then you discover, oh, somebody else already did that. I could have just read it. The other challenge of literature review is you need to make sure when you find results that seem to be matching your case, whether it's actually the same context, the same user population, is it the same kinds of users? It doesn't help you much if somebody finds out that pie menus are faster than linear menus, but they did their study on high school students, and the system you are developing is for older adults. or one system is meant to be used by occasional users who only use it once a month, and you are designing something for experts that are going to be using it every day for many hours, right? So your assumptions have to be fairly similar. Otherwise, you can't just pick up these things that they found without any caveats. Now, the second technique is called cognitive walkthrough. The goal of cognitive walkthrough, remember, we're in techniques where we do not involve users just yet, right? So with cognitive walkthrough, what we do is basically we try to judge the ease of using something and also the ease of learning to use something without actually having users around. It sounds weird, like how could you do that? Well, it's an analytical method, so it follows a certain process. You usually do this only in a very early design stage or with an existing system to get an idea of what's the state of the market, what's the competition like right now, how do people work, with a competitor's products. Now imagine an empty white room, okay? And we're now going to do a cognitive walkthrough. First thing you need is, of course, an Hci expert. So somebody who is a designer or a cognitive psychologist who actually understands the theory behind Hci and the practical implications of usability. So they somebody who at least has heard DIS1, okay? Secondly, you need the UI, obviously, but you don't actually need a fully working prototype. It could actually just be a specification or description of the interface, as long as it's clear how it would work. So a paper prototype, along with instructions on what it does when people press certain buttons on that paper prototype, would be fine, right? It doesn't have to be a working software tool. And now remember the three questions you would always know to ask first when I shake you awake at 3 a.m. in the morning. Who's the user? What's the task? What's the context, right? Who, what, and where. These things mean that you also need to know about the task that people are supposed to be doing. So in that white empty room, there's now an expert. They have an interface with a description of some sort. Like it could be an actual prototype or a specification of a prototype. And they have a document that tells them what the task is like, right? that is supposed to be done with this prototype. Now, there's going to be typically many tasks, but this is one that is spelled out as a sample task, a representative task. For example, if you're doing a banking application, transferring money to a friend, that's a typical task that should be laid out. And then again, who's the user? What's the task? What's the context? We need to know about the user, right? So that you cannot expect the Hci expert to just make random guesses at whether something works well for the users if they don't know what kind of user base you're designing for. In many cases, you have a particular target group in mind for which you are developing. And if that is the case, then this needs to be spelled out as well. So we need some kind of user profile. So there's another document in that empty white room that says, this is a description of our users. Maybe it's a persona, right? A description of a user in this like abstracted way. And finally, we need the context described. We need to understand where are people going to be using this software, right? So it's basically user, task, and context need to be spelled out in some way. And then an Hci designer basically steps through with having all these things, the expert, the description of the UI, the task, the user profile, and context, and takes time, because for each task then, basically the expert goes through and uses a model very similar to what we've already learned in Norman's 7 stages of action. He breaks down the goals that the user must have into intentions and action sequences, and then asks basically himself or herself, well, does the system actually help the user to get from these goals to intentions and actions? Does that work, or are there gulfs appearing during that process? And secondly, what knowledge and also cognitive abilities or processes will the user need for this decision process to be made? So for example, with the banking, mobile banking app, maybe you could say, well, making a transfer, a bank transfer is a typical task. So now I need to drive, the user wants to do a bank transfer. What are they going to start with? Well, they'll probably have, a recipient and their bank code number and an amount. And they will want to somehow put that into a form and send it off. And then probably authenticate in some way so that it's a legal transfer. So this needs to be clear to the expert, and then they need to look at the interface step by step and say, okay, does each step of the interface actually provide the right clues and information for the user to get through that? Or what problems could doing each step have, or learning to do this step have? This is hard. This is hard because as an expert, you need to put yourself into the shoes of the user and see the interface with the eyes of the user, right? So you need to imagine yourself being the user and using the system with the user's background and knowledge and expertise. So this is not trivial. That's why we need that documentation there, so you can look up what the user knows, what we can assume the user knows, what we can assume the user doesn't know. To help this kind of process, you can sometimes have question forms, which means at each step, for example, we now want to do a bank transfer. There could be a form that says, here are the questions, dear Hci experts, that you should remember asking yourself in order to identify potential pitfalls. Like what would the user call this step? What are the typical pieces of information that the user has available at this step? What are likely ways they would expect to be able to input this data into the computer, et cetera, et cetera. So that is a cognitive walkthrough. It's called a cognitive walkthrough because we're basically walking through what's happening inside the brain, right? The cognitive processes of a hypothetical user that's using it. As you can see, tricky business. The problem, apart from putting yourself into the shoes of the user, there's another challenge with this. If you are part of the design team and doing this, you also need to unlearn your interface. You need to forget about your interface and imagine yourself being a user who's never seen it before, right? And this is super hard. We so easily make assumptions about the UI that we forget about them later. So unlearning the UI is a tricky part of this. That's why there is another approach, which is called Heuristic Evaluation. This is a variant of the cognitive walkthrough, but we use a very clearly defined set of questions or rules, golden rules of user interface design that we check the prototype against at each stage. So basically, again, you're stepping through each step of this bank transfer, that you're playing through in the banking app. But at each step, you ask a couple questions, like, is this, for example, is this system as simple to use as necessary and possible for the user? Or does it speak, do the words used in the user interface, are they from the user's domain? Does the user happen to know these names? Does it use the word bank transfer, or does it use the word SEPA transaction, which, maybe as a developer, that's a bank transfer, but the user's like, what the heck is an SEPA transaction, right? So these kinds of things you check against. So at each step, you go through these tasks and you check whether the guidelines have been followed or not. This is much easier and cheaper, therefore, to do, but it is subjective. Why? Well, let's say there's a rule that says, the first golden rule that we'll talk about is keeping things simple. Now, keeping things simple sounds like a great rule, but a Linux geek will say, oh, look, it's a console-based interface with textual input. That's really easy, right? And any other user without much Linux knowledge will say, like, oh, I don't know, that breaks rule number one, right? So you're quickly putting your own subjective filter into applying these golden rules when you judge a system. That's why it's often helpful to ask multiple people to do a heuristic evaluation because they will have different backgrounds and different understandings of the golden rules and interpret them differently, and that will give you a more balanced result. Now, if we want to get a little bit, I should say, with the golden rules, that's something that will come up. We'll go through a lengthy list of usability heuristics, 10 golden rules that you will learn about and that you could apply in such a situation. Model-based evaluation is an approach that you can do if you want to be even more controlled in your process, right? There are some models out there that are incredibly powerful that can give you a framework, a theoretical framework for designing and for evaluating your prototypes. Some examples are GOMS and KLM, and we'll talk about those in the next lecture. They let you evaluate designs mathematically, finding out how long it takes to use a system or how long it takes to learn using a system, literally by computing times and efforts. There are notions of information efficiency that we can measure by looking at an interface and modeling it mathematically. Also something for the next lecture. Two other approaches that I want to talk a bit more about today are design rationale and Hci Design Patterns. Now, a design rationale is a technique in which at each step of your user interface design and evaluation, you make a very careful documentation of your design decisions, giving all the reasons why you decided to pick a certain alternative, but also listing all the other options that you looked at and that you discarded. So for example, if you decide to provide an option to enter a bank code number in your mobile banking app, then you will have to explain why you decided to make that in a text field in which I enter text, and why you didn't decide to instead make this, let's say, a QR code or a camera scan that recognizes things automatically. And you will have your reasons for making that choice, hopefully, but you have to write them down. Now, you could say, well, that doesn't help me in my current process, does it? Well, yes and no. In the current process, making these decisions explicit can sometimes help you reflect already and say, oh, wait, yeah, why did I make that choice? You know, did we really talk about this clearly and discard all the other options? But where this really becomes useful, the design rationale, is in the next project that is in a similar domain. Because then you can pull out your old design rationale and quickly find matching design decisions that you need to make again and go through your list of reasons why you made a certain decision last time. And that can help you save yourselves, you know, repeated discussions about the same interface decisions again and again. So for example, if you've made a decision that you want to be building a system that is compatible to the current OS user interface rather than being compatible across platforms, then that's a decision that you've made and you'll have your reasons for it. And next time the same decision comes up, you can look at your design rationale and solve it. So design rationale builds up a almost a repertoire of design justifications and options and weighing things against each other and going for one or the other that become useful as a body of knowledge, not only to yourself, but imagine, you know, a year later a new colleague joins your team and you want to get them quickly up to speed. They can look at these design rationales of the past projects and understand your reasoning for certain decisions, so they can learn from that. An even more structured and more reusable and easier to read way to do that is in the form of Hci Design Patterns. Now, patterns are almost kinds of like design recipes. They basically provide you with a rationale of a certain design decision, but in a very easy to read and repeatable format. We talk more about Hci Design Patterns in the current topics Hci lectures, which is our research class in Hci that you can take next semester. But I'll show you a little bit of a preview here. Now, design patterns are close to my heart, but because back in the days, I wrote my own PhD thesis bringing HCI design patterns to HCI. They had been used in architecture and in software engineering, but nobody had really used them in HCI yet. So that was the part of my PhD thesis. I wrote a book. My PhD thesis became a book on the topic. And nowadays, you can actually find HCI design patterns used quite a bit in usability literature. So here's an example of an HCI design pattern. Now, this HCI design pattern, I should explain, is a sample from a collection that I published in 2008 or something. And it's a collection of design patterns that are about interactive meeting rooms, okay? And this particular pattern tells you how to address a certain aspect of designing such an interactive meeting room with meeting technology in it. And I call it social protocol. And the pattern has the name social protocol, and it has a ranking behind it with these 3 asterisks. I'm indicating that it's one of the ones where I think you should really follow them. They're very important. They're the probably the most fundamental and most important patterns in the collection that I have. The pattern then goes on, has what you could call a sensitizer or an opening image. And here you see somebody passing a wireless mouse onto somebody else. That's already, the picture is there to make you aware of the topic we're going to be talking about with social protocol. What does social protocol mean? Well, it basically means that when you have a meeting in a room with meeting technology, like, interactive walls and meeting recording going on, you don't want to continue driving the computers all the time in addition to running your meeting. You want the computers to basically be listening in and making some smart decisions based on what they observe in the environment. And so, for example, if I pass my wireless mouse to a friend in the meeting room, I don't want them to also then have to tell the computer that they are now entitled to move the mouse cursor, right? That's not necessary. By passing the mouse to them, I've done everything I need to do, and they should just be able to continue using the mouse. Now, the pattern lays out this basic idea with a context. So this context tells you in which situation this design pattern social protocol is applicable. And it gives you the problem statement here in bold-faced text. Interactive technology likes to be told when something happens or when it's supposed to do something. But people easily forget that extra step, especially when in the middle of a high-energy brainstorming session. Next up in this pattern comes a lot of examples taken from a variety of backgrounds that I collected to make the case for my design pattern. And this is a bit like a design rationale, except I'm also pulling from other people's projects to show why I think this is, the solution I'm going to be proposing is a good one. For example, years ago, I saw a video where MIT researchers were demonstrating a system that was capturing meeting notes automatically. But every now and then, everybody had to stop talking. And then one person would say, computer, record the following sentence or something. It was very awkward. And so this awkwardness is what I talk about here in these examples. And then comes distilled from that, the solution of this design pattern. In this case, don't put unnecessary protocols into place that are aimed at avoiding overlapping access to technology, like 2 people fighting over a mouse cursor. This gets easily resolved, right? Because somebody will just say, hey, stop moving the mouse, right? And the other person will stop. You don't need a computer access system where I need to log in and claim the mouse cursor for myself. So don't put unnecessary protocols in place if that collision can be easily noticed and fixed by the users through social interaction, and so on and so on. So after that comes a little diagram, which basically says there's 2 people talking. You can see here, this was done in my best sort of Starman drawing skills. And the computers basically should just be tapping that social interaction happening between people and should derive its own logic from that. And there could be references to other patterns in the language that you would look at next to further implement and detail out this particular design solution. But in this case, it's basically a leaf in the tree of patterns. Now, pattern languages have been around in HCI Well, they've been noticed. They've been around in architecture and software engineering, and there are some early references, actually by Don Norman in his books in the 80s, including the one that you've read. If you look carefully in the notes, in the annotations, in the appendix, you can find some references to design patterns in there, where Norman called them fascinating to skim, but frustrating to read. He was referring to the original patterns that an architect called Christopher Alexander had written for urban architecture. And in the Apple Human Interface Guidelines in the 90s, you can find references to Alexander's work as well. So design patterns were kind of in the back of the minds of people, but nobody really tried to bring them to HCI. I did that with an example of a pattern language in the around 2000 that was built for interactive exhibits, interactive music exhibits. And here's the pattern language with all the patterns. And as you can see, a pattern language is not just a loose collection of patterns that are unrelated, but they are connected through these contexts and references inside them. The references are links to other patterns further down in the language that are more detailed. And the references are, the context is the inverse of that points up the tree, telling you what other higher level patterns to take a look at before you get to this level of detail. Okay, so that should be enough about pattern languages. It's a fascinating topic. As I said, check out current topics in HCI if you want to learn more about it. This was all the techniques we have available to evaluate without users. So let's, at this point, Haihu, you had a question?
Yeah, I have a question. So we are talking about this evaluation. So, but perhaps I missed it, but how can this pattern language, the Hci design patterns, help us by evaluation?
Excellent point. Thank you for bringing it up. Well, we do actually mention some of that in current topics, but it's a good question. What you do is basically you can actually integrate the pattern language into many steps of the evaluation process. For example, when you start a project, we did this, right? I've designed a couple interactive exhibits over the years. And when I go to a client, a museum who wants an interactive exhibit for the exhibition, at the beginning, I share this pattern language that you see here with them. We have a meeting and I talk through these design rules. They're basically the school of design spelled out, our design values spelled out that we have for a certain project. For example, I always try to make exhibits a cooperative experience. I try to design them so that not only one person can play with an interactive exhibit in a museum, but that several people can interact with it together. Okay? So at the beginning of a design process, I would share this language with the client because they are written in a way that even non-technical people can understand them. They're not too technical and they're not HCI expertise texts. They are really understandable by the average user. And then I use that, I come back to these later on in design meetings because, for example, maybe the cooperative experience requires, as you can see here, an immersive display, which means a big screen. And then maybe, 3 months later in the project, the client says, we would like to save some money by replacing that big wall display with, a 27-inch monitor. And then I can go back and say, well, remember, we talked about this design pattern here. This is why we need the big immersive display. And I can make my case and explain certain reasons for these decisions. So in a way, the pattern language helps you evaluate your design and move your design forward by giving you almost like the golden rules, like heuristic evaluation, giving you a set of qualities of your interface design to check. It's a bit like golden rules, but it's more structured. It gives you more concrete advice what to do. We haven't talked about the golden rules in detail yet, but you can imagine if all that you hear is keep the interface simple, that's great to know. But if you're sitting in front of a blank piece of paper, what are you going to do, right? Keep the interface simple doesn't really give you anything to work with. It's not constructive. It's just analytical. You can only look back at an interface and say, is it as simple as it can be, or are there opportunities to simplify? The design patterns, on the other hand, are actually constructive. They let you at each step of the design process go down the pattern language layer by layer and apply these patterns and flesh out your design more and more, piece by piece. And then in your evaluation phase, and that's why I mentioned it here, you can go back to your design pattern language and see whether your design is actually fulfilling the design goals that the pattern language laid out. Fantastic question, though. Thank you. We should probably at least make a note that we explain that very briefly, because otherwise, you're right, it's a little confusing why we would talk about pattern languages at this point. So the right-hand side of our little tree here. This is something that you should definitely be doing as soon as you have prototypes of some sort available, right? Even if it's just a paper prototype. Always, if you have the opportunity, try to consider evaluating with a user in the room. These are the techniques that you want to apply as early as possible if, you know, funds, etc. allow. Now, we're still assuming that you've talked to your users and you've identified your users and you've hopefully empathized with them, you know, through things like design thinking approaches already, right? You know who you're designing for, and you've made your done your research. But now we're talking about, you know, the artifacts you're creating. How do we begin to roll these out and find out whether we're on the right track with them? And you will see that the techniques E5 through E9, or E5 through E8, I should say, so 5, 6, 7, 8, are actually almost building on top of each other. So each one is a little better, if you like, than the one before, but it also is a little bit more involved, takes a little bit more time than the one before, all right? So let's start with a very simple one. I got a prototype. I show it to the user and I say, what is this? How do you think this works? Okay, literally, I give them a screenshot and say, explain this to me, right? And I see what they say. The basic idea is I just ask the user, do you get the interface, right? Now, this is great in order to just get an idea of what is the first sort of naive, first contact kind of conceptual model that the user develops of the system that we're trying to study here. But the problem, of course, here is that we're not getting an insight into how the system is getting learned over time, right? This is the first time, like I'm showing you the UI, right? You know, here it is, and this is what it looks like. So now please go ahead and explain to me how it works, right? So initial usability is what you can judge with this. If you want to understand how the system is learned over time, we need people to do something with the interface, not just explain it to us, right? We need them to do a task. So far, we've only involved the user here, and we maybe are doing this in the context of their environment. So if it's an interface for people driving trucks, we might be sitting, you know, in the truck with them and showing them the interface, but we're not asking them to, I don't know, plot a course with the interface, right? If it's a navigation system. So next up, silent observation. Here, the designer, who's the guy here on the left, watches the user, the lady on the right sitting, working on one of the tasks that we've identified, right? That we want the system to support in either a lab environment or a natural environment, doesn't matter. By the way, the drawings here and in the following pages are done by my esteemed colleague, Saul Greenberg. And as you can see, they were done back when Mac pluses ruled the earth, right? So, but the technique hasn't changed just because the technology has changed. So the thing here is, this is really hard and unnatural. There is no communication during the observation here, okay? So before that, of course, you talk to the user and you explain to them what they should be doing. So they give them a concrete task and then watch the user do it. For example, using one of those lab settings that you just saw earlier with all the recording possibilities, or just by Well, he's actually standing in a little bit of an awkward position because he can't see the screen, right? You probably want to be more off to the side here so that you can both get the user's reactions, but also see what they're doing on screen. And as I said, you often want to capture this on video and audio too. So the no communication rule is important because we don't want to explain the system to the user, although that's terribly tempting. We want to observe how the user gets along with the system by themselves, as if we weren't there, right? So you're like a fly on the wall, just observing, not talking to anybody there during the test. This helps you discover some big issues, right? If the user really runs into a problem, a major one, you will notice because of what they are doing, what they are clicking. So you will get an idea of what's going on, but they're not especially addressing you or talking to you about the system or talking in general. They're just doing their task and like they would normally do it without speaking really. So what we're missing here is the understanding of why people are making mistakes. You might observe the user clicking on a print button, even though the print button is grayed out, and they might be doing that repeatedly. But you don't know what part of their conceptual model is currently different from what you were envisioning it to be. Notice that I'm not saying it's wrong, right? I'm saying they have a conceptual model, and that's just as right as your conceptual model. You just didn't succeed in getting your conceptual model across correctly through your interface design. So it's your problem, not the user's problem. So we're not hearing about their mental model, right? They're not explaining it to us. We're also not getting their opinions on the user interface. Like, oh, this is a very nicely laid out way. This matches exactly how I would imagine my task to work, or their feelings to it, right? Oh, that looks, the colors are really terrible in this UI, whatever. We're not getting any of these things. You just observe. So challenge number one is you're missing a lot of information, of course, right? Because you're not hearing these things. You can't look into the user's brain, right? You can't understand what's going on inside it without them expressing it, and they're not expressing it in this technique. The second challenge here is, this is really hard. This will be one of the toughest moments in your life when you have built your DIS1 prototype and you give it to a user and you have them use it and they fail with it and they make mistakes and you can't say a thing. That's so hard. You always want to go in like, no, 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 you have to press this button. Isn't that completely obvious, right? And you're not allowed to do that. That's the challenge of silent observation. A colleague of mine who once, many years ago, worked for Microsoft said this was one of the most rewarding moments in her life when she got her engineering friends at Microsoft to stand behind a glass wall and have users inside a test room use Microsoft, I don't know, Word to create, a letter. And they had a simple task of, I don't know, inserting a picture or something. And the users failed doing this task and clicked all the wrong buttons. And these engineers were behind the glass wall. No, you can't press this. But of course, they couldn't reach the users, right? They couldn't help them and tell them what to press. And this was a very sobering and rewarding thing. After that, I think they listened to her as a usability expert much more than they did before. Because before, you can't imagine the kinds of mistakes people make with your interface. It's totally obvious to you, so why shouldn't it be obvious to them? And this is really a humbling experience to see how people fail with your system. I've been through that myself, watching people use our music exhibits that we've built for museums and the likes, or our mobile guide systems that we've developed for various cities and expos, has been quite sobering, right? You would never think how wrong you can be in sort of assuming the mental model that you are communicating. All right, but in order to solve some of this, there's a better way to do this, or a more elaborate way of doing this. I don't want to say a better. You do think aloud, which is technique E7. Now that means it's like E6, like silent observation, but now the user is actually asked to talk aloud. And what we ask the user to say is what she thinks is happening. So the current state of the system in her observation, how she interpreted, what she's trying to achieve, essentially the goals from our 7 stages of action model, and why she's clicking, pressing, dragging, selecting something specific. So the actual actions, right, from the 7 stages of action. So you then get to actually understand what the conceptual model is that the user has, why mistakes are happening, why something works well or not well. And this is the most commonly used method in industry, even today. It's really great because it gives you some insight into how the users are thinking. But there are some challenges with it as well. First of all, it's actually mentally demanding to talk about the task you're doing while you're doing it. We're not built that way naturally. When we really focus on a task, we are not usually able to easily also talk about it as well. So it's a little bit unnatural. It's actually more than a little unnatural because there's nobody that the user can talk to, because they're not actually, you're not allowed to talk back, right? The experimenter, the guy on the left here, is not allowed to say anything, still a quiet person. He's just listening to what the user is saying. He's not allowed to respond. Because we want to avoid the designer giving tips to the user here that helps them solve the problem, because that's not the normal usage situation. So it feels weird for most users to just talk aloud, maybe even alone in a room with recording equipment around them, right, in a lab setting. It's a weird situation. There's another interesting effect called reactivity, where if you talk about a process consciously, if you express it in words, you will actually act differently because you're thinking things through in order to say them. And that sometimes makes you reflect on things differently than you would if you just went ahead and did it. So that conscious talking can change the behavior of the user as well. So that's think aloud. Still, like I said, very popular, very often used in industry to get an idea of how your interface prototype is doing with the user. If we want to remove some of the weirdness here, we give that user somebody else to talk to. And that then is constructive interaction. And here we added who I'd like to call Neanderthal man because of his weird nose. So we have 2 users here that are working together on a task. And they converse normally. They're doing the job together. They talk normally together. And you observe that normal conversation as a bystander, basically, right? You're still not talking as the experimenter on the left here. Of course, you also record these things if you can, and it makes it much more comfortable than think aloud. And let me add one here. You could say that's version E8.5, so to say, or version E8 on steroids. That is when you don't just put 2 random users in front of your system, but you actually pick one who's never seen the system, Neanderthal man here in this case, and you pick another one, the lady, who actually has already seen the system and has a bit of has seen your prototype before, maybe used it for a bit in a think aloud session herself. And that then gives you an interesting insight into 2 mental models, the beginner's model of the guy and the advanced users model of the lady here. And you see whether mistakes that maybe the beginner's model has rectify themselves, whether misconceptions that a user has of the system because of a bad design decision rectify themselves through some time of use. Or maybe, and that's the more likely thing to happen, you will hear all sorts of weird explanations why the system is doing something in a certain way, which shows that the advanced user has actually built her own model, her own mental model, explaining the causalities in your system with her own reasoning, because, you know, she doesn't know why it's happening, so she's making up her own explanations for it. And that's more likely to happen. So we have a semi-expert lady in this picture here as a trainer, and the newbie, the gentleman here, as a student. Student then tends to use the UI and asks, and the trainer answers, right? It's not you, and not you as the designer. And this gives you insight into both of these mental models. So you can see why I say like 5, 6, 7, 8 are really stacking on top of each other, getting more and more complex, more involved. Now you need actually 2 users, right? Not just one. There's more data to capture and to go through, but they also give you more and more insights into what's going on. E9 is not building on top of the other ones, but is actually more of a orthogonal thing that you can always do as an additional activity. So let's say you've done an observation, maybe even a silent observation where you haven't really heard something. And there you can now go in and look at the actual interaction of the user together with the user on a video recording, right? So you record what the user did, and after the user's done with the task, you go over the video together. And then the user can comment on his actions retrospectively, which means it's actually a little bit more natural to do it that way than having to talk aloud while she's doing it. So you can let them work silently, unless they really feel like they want to say something. And then they can afterwards, they can comment on their own actions. That's advantage number 1. It's a bit more natural. Advantage number 2 is this discussion now is happening with the actual actions of the user in front of everybody. So there's no chance for false memories of the user saying, yeah, I didn't have any problems, right? When we can clearly see in the video that, you know, she clicked on a grayed out button a couple times, right? So it avoids these wrong memories, and is also a great way to lead into an interview kind of session where you, for example, ask for suggestions for improvement. Often these kind of discussions, like in this example here, I didn't, you know, do you know why you never tried that option? I didn't really notice it. I didn't see it. Why don't you make it look like a button, right? So you can see we're beginning to have a design discussion then, and you can go back over the video and re-roll it if there's a question. So that's nice, right? You don't need to interrupt the actual session. The video is something you can look at afterwards together. Which brings me to the topic of recording observations. We've already said that capturing video is a good idea, but you should not ignore the power of taking written notes. Paper and pencil or typed notes are really important because even if you tape your entire session and during the session you just space out and you're like, oh, it's all on tape, I'm good, you will have a hell of a time later on finding your way through all your material. So make good use of the time when you are recording to already write down the key events happening. When does the user start, you know, for example, working on the bank transfer, and when did problem number X occur? When did problem number Y occur? When did the user backtrack to an earlier page in the dialogue or something? When did the user become, you know, nervous because they didn't complete the task? When did they get confused? When did they make a mistake? Make all these notes and timestamp them, right? Just write down, you know, 10:32, this happens. This is incredibly useful because it already gives you an index into your video, right? You already have your first level of structuring your video recording in order to work with it. Writing is slow, you know, so you'll be surprised how little you can write down when this interaction is happening. Also, this only works if you're not otherwise occupied, right? So this doesn't work if you're having an interview with somebody, then you can't take a lot of notes while that's happening. You might need somebody else to take these notes for you. But if it's a silent observation, you know, you can take notes, right? That could work. You may want to use maybe either a software that automatically timestamps your notes for you, or even does some more elaborate form kind of based note-taking. Also, the recording that you do is basically something that you are indexing through these notes. So what's the recording? It could be just an audio recording, which is okay for speech with think aloud and constructive interaction techniques. But audio recordings are incredibly hard to connect to the actual state of the interface, because the user might say something like, oh, I didn't know what that button is good for. And you're like, okay, what button is she talking about, right? So you clearly want a screen capture, or maybe a camera view even of the user on with their hands on the keyboard and the mouse, etc. So you can see what they're doing. Because sometimes, a mouse click that's not happening over an active area, if the user is clicking on something outside the normal, that's grayed out, you can't see that click on the screen capture, right? Because nothing happens in the UI as a result. So you need to actually see the finger going down on, on the mouse button. Or keyboard shortcuts are also really tricky. Suddenly the interface, some dialog pops up and you're like, okay, what happened? You need to know that the user pressed a key to do that. So video capturing is usually the best way to go. You want a camera that shows the screen, or oftentimes you can capture the screen directly in software. And you want the user and the user's hands maybe. Ideally, you have everything in one picture, put together. If not, then you need to make sure that you can synchronize the two. Welcome to Video Production 101. You've got two tracks and they need to be synchronized. You need some moment that happens in both, the famous clap that tells you where these two things, at what moment in time they are actually synchronized. Otherwise, you don't know. Video is, of course, the best way to capture things, but it can be a bit intrusive, right? So you need to make sure not just to talk to your users about how these videos are going to get used and how they're not going to get used. They're not going to get used to post them on YouTube under like funny user mistakes I observed, right? And you need to use some dedicated tools to analyze video. Video analysis can take hours and hours of your life. It's really a tedious task, and I think many of our PhD students, Ollie is nodding his head gravely. Yeah, he's been through this. It can take a lot of time. There's good software out there. MaxQDA is an example. ChronoViz is another one. These software tools can actually help you make these markings in your videos a little bit more effectively. What you often do then is you go through your video and you make notes with timestamps linked to the video of the activities in the video. And that can be something you maybe already start doing while the video is being recorded. And then you go through and you compare these things and you classify them into user errors or moments of surprise or smooth sailing, whatever. And it's an elaborate task. Okay, so that takes us through the qualitative methods. You've seen all of the things we've done here don't really give you numbers like, the user was 5% faster or made 5% fewer mistakes. That's not really what this is about. It's about getting the reasons for mistakes and seeing the qualitative issues with the system. Now, if you want to get to numbers, and in science, we often do want numbers. We often want quantitative results, although qualitative results of observations can be just as valuable and just as publishable. But we often do run quantitative studies to measure, for example, whether an interface is actually faster than another one. So these controlled experiments are the next section here, E10, and they cover the quantitative evaluation with users. Controlled experiments are a quantitative empirical method, right? How do you do it? Well, basically, you change a variable, we call it. You manipulate a variable, and you measure something as a result. We have an example here. We may have a bunch of users. We ask them how many times per week they are gaming. And that's our variable. And based on that variable, we then also find out in an experiment how fast they can type in words per minute. Okay, and maybe we get a plot something like what you see here on the screen. Now, the graph is mocked up data, right? We made that up. And this data is correlated. We can clearly see a correlation here, but that doesn't mean that there is necessarily a causal effect. Sorry to say. I'm sorry to say, I can tell you that if you play more video games, you will become better at typing, right? That's not what we can derive from this data. We just see a correlation. Correlation and causation are not the same. Super important basic lesson of statistics and HCI studies and everything else in your life. So we use controlled experiments to move from just these correlations to actual causal effects, right? So we want to identify the cause of a situation or event. We want to understand that X, the average gaming time per week, is actually responsible or not for the typing speed in words per minute. We want to find out whether that is actually a causal relationship. So for that, we need to directly manipulate and control variables. So correlation does not imply causality, as I just explained with the graph here on the right. So the way we do these controlled experiments is we manipulate and change one variable. We observe the effects of that, and we do this in a controlled fashion. That's why it's called a controlled experiment. And we use them to verify an observation like the one we plotted here on the right-hand side, like a correlation, or maybe just a hunch that we have. In this concrete example here, there could be all kinds of explanations for the correlation. Maybe playing computer games actually does improve typing speed. It's possible, but we haven't proven it yet. It could also be that people who can type fast also tend to be people who, because of their social profiling, their psychological profiling, like to play games and therefore spend more time playing them. Or there could be a third factor. Those who are fast readers also are fast typers and also happen to be people who play more games. That would be the hidden third variable, like reading ability could be influencing both of these things, gaming time and typing speed. That's another explanation that could be statistically true. So just to show you, correlation and causality are tricky to determine. How do you run a controlled experiment? We got 6 steps, and we'll take you through each of these steps in turn. This is a little bit more detailed than what we've done with the other qualitative techniques here, because if you do your thesis with us, your bachelor of master's thesis, you are likely to do something like that as part of your work to evaluate your prototype that you may have built in your work. Not necessarily, not always, but many times this is needed. So here's what we do. We formulate a hypothesis, we design an experiment, we pick the variable parameters and the fixed parameters. We run a pilot study where we're basically testing our experimental design. We debug it, and then we choose and recruit our subjects. We run our actual experiment, that's when it's happening, and then we interpret, and discuss the results to accept or reject a hypothesis that we've identified. So let's look at each of these steps in turn. First step, formulating a hypothesis. Here's an example of a hypothesis. Selecting menu items in an on-screen menu is faster if the menu is pie-shaped than when it is linear, right? That's a valid hypothesis. I'm not saying it's true. I'm just saying that's a hypothesis that I could set out to test with a controlled experiment. So a hypothesis is a statement about something that might be true. Step number B then means designing the experiment, picking the variables and fixed parameters. In this case, we would say, well, the menu type, pie menu or linear menu, is the variable that we change, right? It's the variable that we control, we say. We change it in a controlled fashion. And what the parameters are that we're going to measure then is, for example, how fast people are to select a target, right? To seek out a target on screen with this menu, to select a particular menu item. Then, as I said, we would run a pilot study to debug our experimental procedures. In this case, that could be that we go ahead and improve the distribution of the menu targets around the pie and the linear menu to avoid any bias, for example, or to make them harder to learn by heart and to remember. Because if you made the let's say you made the 6 menu items that you select are actually labeled A, B, C, D, E, F, or 1, 2, 3, 4, 5, 6, then you got a problem because people aren't actually going to select from the menu. They know exactly that 5 is at the end, almost at the end, and they will go there directly in a Fitts law kind of task, right? So you want these menu items to actually be, you know, well randomized so that they are not easy to predict where something is in the menu. By the way, what we're showing here is a simplified version of an actual experiment that somebody did. Callahan and colleagues at Hci 1988 did an empirical comparison of pie and linear menus, and you can read that paper if you want to see how that actually was done at some point in order to determine how well pie menus work. In step D, we said we recruit subjects, right? So, for example, you could say, well, I'm going to choose the most widely studied population in the history of mankind, which is undergraduates in, you know, computing and sociology and psychology and these kinds of fields, right? They always get picked as study subjects because they're around, they're cheap, right? And they're willing, so they always get picked as study subjects. Interestingly, if you read the paper by Callahan, you'll find that back in 1988, the consistent experience level that they chose was, we want people who had little or no experience using a mouse. Remember, this is only 4 years after the Mac got introduced. Not everybody had been, you know, by far, not everybody had been working with graphical computer systems at that point yet, right? So it was easy for them to find undergrad students who hadn't used a mouse before. I challenge you to do that today. It's probably pretty tricky. Well, and then you run the experiment. Each participant just performed a menu selection. Let's say for each type of menu, you do 10 menu selections with different items to pick. And then you interpret the results to accept or reject the hypothesis. For example, you know, the experiment found the mean time to pick an item from a menu was 2.26 seconds on a pie menu versus 2.64 seconds on a linear menu. And of course, this is the mean, right? The average. There are distributions around that mean. And by analyzing these statistically with the right methods, you can determine whether this difference is actually statistically significant or whether it's, you know, two curves that overlap so much that you cannot make a significant claim from that. That's, you know, your average statistics knowledge that you guys might remember from your statistics lectures in undergraduate studies. In this case, it was actually statistically at p equals 0.0003. So that's an example of the steps of a controlled experiment. Now, a couple words about subjects that you pick in your controlled experiments. I mentioned that, you know, oftentimes people just pick undergraduate students because they are around, you know, their own colleagues, their own co-students. But if you really want to find out something, you're doing this as part of, you know, a research project or an industry, you want to find people who are similar to the actual users that you have in mind, right? You know, not just age, which is a typical one that people use and which is actually less interesting than people think, but education or computer expertise or domain expertise or knowledge of a particular system. And you could, for example, run a study and pick all like computer experts, but maybe you're running your study on a Mac and half of your people are experts on a Mac and the other people have only used Windows all their life. So those people are not all going to be performing the same in your study if it's running on a Mac, right? So be careful about computer knowledge in general and knowledge of a particular system and even application in particular. There's long discussions about how many people you need, and you can actually compute the number of people you need if you are looking for a certain power of your measurement. But a very quick rule of thumb is to start with at least 10 subjects and use more if you are looking for finer details. Like if you really want to measure differences in these, like, you know, tenths of a second of performance, then, you know, 10 might actually be too low. Statistical power analysis, as I said, can tell you an exact number that you need for a result of a particular predictive power. The other thing is that you need to determine your variables, right? We already saw an example. There are two kinds of variables in these experiments. They're independent variables, IVs. They are independent because they are varied under your control. So you have them under control. They're not influenced by the experiment automatically. The example here would be the number of menu entries, but also, of course, the kind of menu, right? So the menu type would be the most interesting independent variable here, but the number of menu entries that you use is also a variable that you can control. And each different level of an independent variable is also often called a treatment in the literature. The second kind of variables you have is dependent variables, and these variables are the ones that you measure. They depend on the choices you made for the independent variables. Typical examples in HCI are execution time for a task. How long did it take somebody to do a task, like picking a menu item? Or error rates, how often did they hit or miss the right menu that they were supposed to pick? Or subjective preferences, which interface did people like better? Now you might say, wait a minute, subjective preference? That sounds very qualitative. That's all like, you know, very fuzzy, and people are going to say, I like this and I didn't like that. Well, you can actually ask people to rate something on a scale, and then you can use the numbers from that rating and use them as for a quantitative analysis. Nothing against that. You can say there's a significant difference in the quantitative rating of you know, how much people like this system versus the other one. That's definitely possible. So just because you're going by what people say rather than what you observed doesn't mean that you automatically move to qualitative versus quantitative. Don't mix these two up. Okay, now I'm going to need your brains turned on for a bit. We're going to do a little bit of an in-class exercise here. We're going to identify some independent and dependent variables for each of the following three scenarios, and these scenarios will come back to us. First one, imagine you're doing a study investigating whether people who have attended a security training program generate and use more secure passwords than people who have not received any security training. What's the independent variable here? Just raise your hand. Yeah, Hua, go ahead.
The independent variable is whether the people have attended a security training.
Or not, exactly. So it's a yes or no. It's a binary variable with just two possible values, yes or no. Exactly. And do you want to continue and tell me what the dependent variable is?
And the dependent variable is whether they will use more secure passwords or not.
Right, right. And we see already, oh, that's a little trickier, right? Because, wait, we need to tell how secure a password is. So I don't know about you, but that doesn't tell me yet how I measure that. With the independent one, yes or no, you know, security training received or not, that's easy. But judging the level of security for the password, we need to become a little bit more explicit about how we do that. We could also say here, we could take every password and look at its security level that they use, or we could classify password into secure and insecure and say how many were secure versus how many were insecure. We got different ways of measuring that. Okay, but that's great. Thank you very much, Haihua. We got another one. A research team is examining the effectiveness of joysticks and trackballs for selecting static and moving targets. What are the independent variables here? Again, yeah, Shailesh, go ahead.
So the independent variable would be whether the people have already, do they have experience with joysticks and trackballs?
Not quite. We're not talking about the experience with the device here. It's a different question, right? It's a different question. Felix, you want to add to that?
Yes, I think the independent variables are if they're using a joystick or a trackball, and then if they are selecting a static or moving targets, and then I think each combination of those two variables.
Exactly.
So joystick, static, joystick moving, and trackball static and trackball moving.
Correct. Very good. So the one that we mostly set out to study here is obviously one understand how joysticks compare to trackballs, but we're actually we're adding the secondary independent variable here, where we're not just saying just for selecting targets in general, but we want to understand both how does it perform for static targets and for moving targets. So we want to make a more detailed statement in the end, right? And so that's why that is also an independent variable. And you're right, the treatments of both of these, each has two treatments. Target and device have two treatments. The target could be static or movement, and device would have the treatments joystick or trackball. For each of these, we've got these two different states, and that leads to 4 different combinations of independent variables, each of which we would have to test with an appropriate number of users to get statistically relevant results. So as soon as we add more independent variables here and more treatments for one variable in our experiment, of course, we're also increasing the number of test runs we need to do. And that often means we need more users, which is often a challenge. So be careful not to ask too many questions at the same time, because this combinatorial explosion can quickly break your experimental design because you just can't find enough people or have them spend enough time to do all of your combinations. And Felix, while you had a run there, do you want to tell us what the what could be possible dependent variables?
Yeah, I think maybe the effectiveness, however this is measured, like for example, the time they need to hit the target or something like that.
Good. So for example, speed, the time to hit a target, or it could also be how precisely they hit the target. We haven't said that yet, right? We haven't said more about this. The research hypothesis, as you can say, is still a little bit grainy, right? It's a little bit rough. We're going to flesh that out more in the next section. And great, we've got another one, a research team examining whether virtual teams who use video chats are more productive than teams who use text-only chats. Very relevant right now with everybody being on Zoom. So what are the independent variables here? Okay, Haihua, go ahead. I'll give that one to you again.
Okay, thank you. I think the independent variables is the teams using video chats or using video chats or text-only chats.
Yes, exactly. That's the independent variable. The method they use. And what's the dependent variable, you think?
The dependent variable is the productivity of them.
Yeah, boy, and don't you hate that, right? That's so hard to actually quantify. How do we measure productivity? We could probably get a Nobel Prize if we knew how to do that. There are some proxies that you could use for that, like amount of distinct ideas that get generated in a meeting, or how satisfied the people are with the tool, because that kind of will probably reflect on how productive they are with it. But they're all just proxies for productivity. Productivity is really tricky to measure, right? Okay, great. So now about the hypothesis? The hypothesis predicts an outcome of the experiment. It's usually a claim that if I change one of the independent variables, it will influence the dependent variables. That's usually what we claim will happen, right? That's what we hope to show. And the goal, therefore, is to confirm our research hypothesis, which we call H1. As Albert Einstein said, however, no amount of experimentation can ever prove me right. A single experiment, however, can prove me wrong. And that is why we use an approach where we reject the inverse of our hypothesis, which is called the null hypothesis, H0, which means we are gonna, in order to show that there is a likelihood of an impact from our independent variables onto our dependent variables, we will show that assuming that there is no impact is exceedingly unlikely. And that is the null hypothesis that will get rejected. Because if we can determine that H0 is wrong, we can then accept that H1 is true, naively speaking. The H0 is usually a very precise statement, and we will actually know the probability that H0 is incorrect. For example, with these gaming, non-gaming things, our H0 would be the average words per minute between gaming and non-gaming groups are equal. And then our data, that's our H0, which we will then reject by showing that our data indicates that there is an extremely low probability that H0 could still be correct. That's because with H0 being correct, that correlation that we saw would have to be attributed to random chance. And that, as you saw, the correlation didn't look like a random thing happening, right? It's quite unlikely that that distribution came out randomly. And that amount of likelihood is what we can measure. Okay, so that's the idea. And then here's something important to understand. If you run your study and it doesn't work out the way that you expected, you cannot reject H0. This doesn't mean then that you can accept H0. What I mean by this is, if you run your experiment and, for example, you find that your null hypothesis is average words per minute between gaming and non-gaming groups are equal, and you run it and you try to reject it with the experiment you did, and the rejection fails due to the numbers that the statistic give out, then you cannot say, oh, I've now proven that the average words per minute between gaming and non-gaming groups are equal. Remember Einstein's quote, right? You haven't proven H0 to be right. You can only say that you have not been able to reject H0. There could be all sorts of reasons. Maybe H0 really is right, but maybe you didn't have enough participants to get a statistically significant result that would allow you to reject H0. So there's a variety of reasons why this could happen. So let's do another one of these in-class exercises and identify a few hypotheses. I want you to take these things that we just talked about and now identify a research hypothesis. So let's start with the one with the security training program. Can you give me, and this is not much different from what we've done before, it's just about the wording, how we express it. What's a good research hypothesis for area A here, for this first team? Felix.
That people who have received or attended a security training program use more secure passwords.
Yes, I would probably quantify it a little bit more. I would say you need something like more secure needs to be quantified more. Like, for example, you could say the average security level of passwords measured with some mechanism that you have to tell is higher, right? Is significantly higher than with those people who haven't received the training. And what's your H0 then?
The opposite hypothesis that they don't use significantly more secure passwords.
Yes, the average security level of the passwords in both groups would be the same, or you could even say is not higher, is not significantly higher with the people who have been trained, because it could even be significantly higher with the people who have not been trained, right? That's also theoretically possible, and you may not want to exclude that possibility. Good. Number B, joysticks and trackballs. Want to throw out a hypothesis here? Anybody? You can just decide to go for one of these things. You don't have to include all the different treatments for all the variables. Yeah, Felix.
I mean, it's up for debate, I think, but one could choose like the hypothesis that joysticks are better for moving targets and trackballs are more effective for static targets. But yeah, that's just one example.
Mm-hmm. Exactly. And if you said, for example, joysticks can move like a matching target, can catch a moving target faster than a trackball, then what would be your H0 for that part?
That H1 doesn't hold, so that I don't know which way it was, like joysticks are not significantly better for selecting moving targets than trackballs, and
exactly
the other way around.
Yep, exactly. So there's no speed difference, or you said it even better. It's like, you know, they are not significantly faster, right? And the third one, virtual teams, video chats. Let's take the idea with the number of ideas generated as the measurement that we do in the independent variables, right? So we count ideas, which in its has its own box of worms. Hua, go ahead.
Teams who use video chats have more ideas than teams who use text-only chats.
Right, exactly. So again, you would say average number of ideas generated by the teams with video chat is higher, significantly higher than average number of ideas generated by the team without the video chat or using text only. And then, of course, H0 again would be the reverse of that. The average number of the ideas of two groups are the same, or it's not higher. That will be the exact H0. Just saw the question about why others aren't taking breaks. So I'm glad you're enjoying the short breaks. I find these very important to give your body a chance to kind of like reactivate, maybe close your rings on your Apple Watch or whatever you need to do to get your stand hours. The reason why our class is so long is that usually when we teach this in person, we have long studio sessions where we work on prototypes and where we engage with people in design meetings, etc. And that's why we have one big block on Wednesday mornings doing this rather than separate sections, because the setup and teardown for doing this would actually waste quite a bit of time. So that's why our classes are a little longer than you might usually have. But I'm hoping the breaks help you to make it through. Okay, so onto the basic experimental designs here. This is a bit of stuff what I'm telling you now that will be useful in a variety of settings for you. First of all, you will be able to use it in doing your own experiments here as part of the DIS1 class when you run studies. It will be useful if you have to do any other kind of experimental work in your thesis, for example. It's actually something that you've probably heard a bit about in the statistics classes from a very sort of theoretical point of view, and now I think we'll see the actual practical relevance of all these statistics details that you learned. And I think this class is unique in the computer science curriculum, since it's pretty much the only one where you are actually being taught a different kind of academic and scientific method than in the rest of our curriculum, which is empirical research. Empirical research is not something that the computer science curriculum normally teaches, and that's why I think it's important that you pick up that additional skill. It's the way that much of science works, right? From chemistry, biology, all the natural sciences, psychology, they all work like this, physics, and we tend to ignore this in computing. But with this knowledge, you'll at least get an idea of how that tool set of academically rigorous methodological studies actually functions, and hopefully get a better understanding for that. So let's get started. We're going to look at, first of all, the question of, you're going to do an experiment, a controlled experiment. You've got your hypothesis straightened out. Now you need to decide who of your users will be doing which condition or variant of your experiment. And there's two fundamental approaches here: between groups and within groups. And I guarantee you, you will mix up the terms because they're easy to confuse. So try to find yourself a good explanation that makes you remember these things. A between groups design means that each subject, which is the name for a participant in an experiment, each subject only does one variant of the experiment. With variant, we mean one particular set of independent variables. For example, video chat versus text chat, right? A team that does video chat is one subject as a team, and a team that does text chat is another subject, and each only gets either text chat or video chat. Your team that does video chat doesn't always also do text chat. This means that there are two things, two groups that you are creating. You are creating at least two groups. One is the control group, and one is the treatment group, right? So, for example, if you had a fancy new pair of AR glasses to help people, I don't know, navigate the streets of Aachen, then your control group would be not using those glasses, and the treatment group would be using your glasses. This comes often from the medical sciences, this term, where the control group is, a group that gets no, medication or treatment, medical treatment or a placebo, and the treatment group actually gets a new medical treatment, and you measure between those two kinds of things. But if you have three different conditions that you're testing, then you got three groups, right? That's quite easily possible. The big advantage of doing a between groups design is because every user only does one version of your experiment, there is no learning effect. So any kind of tasks that are simple and that involve very limited cognitive processes like tapping, dragging, visual search, you can easily do it in this way. Because with the between groups, you are actually dividing your user base in the middle, right? I could walk into class. If we had a physical class, I could say, everybody sitting on the window side of the room, you will do pie menus. Everybody sitting on the side towards the exit door, you will do linear menus, right? That would be possible because picking an item from a menu is a simple cognitive task. And my thinking behind this is that with simple cognitive tasks, the fundamental performance levels between people are actually not that great. When it comes down to fundamental things like reaction time or stuff like this, or visually searching an item on a screen, people aren't that different. So it's unlikely that I create bias by just splitting my user base in half. It's unlikely that all the people who got drawn to the window seats in the room are also the people who happen to be faster in picking a menu item, right? That's very unlikely. So that's why between groups is okay. Understand that between groups always introduces that risk of having a bias because one group tends to just perform better than the other for reasons of picking the two groups, right? That has nothing to do with the different treatments they are getting. The other disadvantage, of course, of between group is you need more people, right? You need twice as many people because each person only does one of your two conditions or more conditions. If you have four conditions, you need 4 times as many people as you would with the within groups design, which is the other option. In a within groups design, each subject does all variants of the experiment. You need fewer users. And the big advantage, of course, is that individual differences get canceled out. This is great for complex tasks, such as typing or reading or problem solving or composition. Why? Because here people actually differ quite a lot. Problem solving skills are widely different between people. And if you did a between groups experiment, the individual differences might easily overshadow the effect that you're looking for. You might end up just, maybe all the smart people, so to say, end up sitting at the window side of the room, and all the dumb people are sitting near the exit side, away from the light, and then all of a sudden I have a smart group and a stupid group with my between group split in the middle of the classroom. And that sucks, right? That now ruins my experimental results because I'm not testing things with the same kind of cognitive skill on both sides. So complex tasks, problem solving, creativity, this kind of thing, don't go for a between groups design, go within groups design. The problem, of course, of that setup is that you now may actually get learning effects, because within groups design means that everybody gets to do both kinds of experiment. For example, use pi menus and linear menus. And that would then mean that they could actually learn something from the first time they do the experiment that they then use in the second time they do it, which would then skew results. Learning effects we'll talk about more. There's not just learning, there's other effects that can happen across these groups, but that's one example. All right, I know this is a little tougher, but let's do this again. We got our 3 studies. The first one is the study investigating whether people who've attended a security training program generate and use more secure passwords than people who haven't received any security training. What would you do? Between groups or within groups? You basically, to answer that, have to ask yourself 2 questions. First of all, is within groups even an option, or do we have a learning effect that we could not ignore? Then we have to go between groups. And then secondly, you can ask yourself about the cognitive level of the task. Felix, what do you think?
I think within groups is here only possible if the security training program would be in between both stages of the experiment. So if the security of their passwords is measured beforehand and then training occurs, and then afterwards the password security is measured, but I think this scenario is very unlikely, so it would rather be between groups, I think.
Exactly. So unless you have the chance to actually make the security training happen as part of your process, and thank you, Felix, that is a smart approach, and we've actually used a similar model in our own experiments at some point when we introduced a teaching aid. We just looked at the the student performance before, and then we introduced the teaching aid, and then we measured again. But if you can't do that, then you have to go between groups. Absolutely. The training would have a learning effect that cannot be undone. You cannot unlearn your training. B, joysticks, trackballs, static and moving targets. So do we have do we have to go between groups because there's a learning effect? And then what's the cognitive level? Shailesh.
Okay, so I think for this, between groups would be better because you could have people who, you could have one set of people given joysticks and one set of people given trackballs. And for this, the learning effect isn't that much because it's based on reaction time a bit. Of course, they can get used to the joystick or the trackball, but if they're selecting like a static or a moving target, then it isn't really, the tasks are quick, so they could kind of get used to it, but not really.
It depends. I mean, I think when you look at the task, the learning effect of using the joystick. Oh, Ziyong, you wanted to add something? Go ahead.
Yeah, like is there always a strict line between a between group and a within group? Because for this example, I could imagine something like in between, where they choose where you split the group into between groups for the joysticks and the trackballs, but for each between group, you then do a within group for the static and moving.
Yes, that is absolutely possible. You don't have to take the same choice for each variable. You're right. But in this case, I think one of the issues that you would face with the study is that if your experimental setup is sort of the same, like this target acquisition, they might learn something doing it with the joystick, which they could then use later on to their advantage when they use the trackball, or the other way around, depending on which one they do first. So here, you would probably still go for a between group approach, also because it's target acquisition. So we don't need to be concerned about it being a highly abstract, creative thinking task. It's a fairly basic cognitive task. It's something that you could teach a monkey to do, is kind of like a way to describe it. So we don't need to worry too much about huge differences between people. So between groups would be a good choice. Now moving on to number 3.
If I could add something.
Oh, Sion, go ahead. Yeah, go ahead.
Another question as well. Is it for within group, is it always necessary that we test the entire group once for variable A and then for variable B? Couldn't we eliminate the learning by splitting it into half, right? So we have half of the group do task A first and then B, and then the other half does B first and then A. And that
yeah, you're a natural, Xiong. That's coming up on the next slide, actually.
Okay.
Yep.
Okay.
Absolutely. That's going to be addressed by how to address the order effect. It's called randomization, and there's a couple of approaches we can do that, and that actually can alleviate some of these effects. Absolutely. But let's for now assume for a moment that we need to make the assumption that we have to pick within group or between group. What about number C here? Video chats or text-only chats, make them more productive. We already said that we're going to measure the number of ideas, the average number of ideas generated by each team to judge that. Felix.
Yeah, I think this is another difficult one because the creativity of the users who take part in the experiment is very influential. And so you would think that within group is the way to go, but I think you have to choose a similar context of the experiment in order to be able to compare the results, and therefore doing the same experiment with video chats and then with text-only chats afterwards, there would be like a learning effect, and the same ideas would come up if the topic is similar.
Right. So that's what you don't do, right? You're absolutely right. You would basically then give people different tasks so that they don't have to come up with the same ideas, obviously, but they would have to be tasks of similar complexity and difficulty. And then you would give the same team the chance to do both treatments. So it would be within groups design, because the task of creative problem solving is definitely high order task. So there are going to be huge differences between people. So between groups is very risky. And we don't need to fear a learning effect if we change the task, if we change the problem that we give people. Of course, the problem then has to be comparable in difficulty, which opens up another box of worms, but a can of worms, but that's just the life of the experimenter. So, Hua, I need to move on so that we don't go too much over time, but stick around afterwards if you have another question, and we'll be happy to discuss it, okay? All right, thank you. Because I want to get to the order effect here. As we just saw, and you mentioned here, the order in which we present the treatments could affect the dependent variable. Like there's the learning effect, which we already discussed. I picked up something in the first experimental part that I can then apply again in the second one. There's also a fatigue effect. If the exercise is to lift weights, and once I have to do it with one kind of braces and the other one I have to do it with another kind of braces, then I'm going to perform worse the second time because I'm just tired. And that same is true for cognitive tasks to a certain degree. And then there could also be other effects. Simply because you do the first treatment, it could have all kinds of effects on the second treatment. Maybe you develop an aversion to a person talking in a video, and that then applies when you see that person again in the second part of your study. So that's a problem. There are a couple solutions to this. The first one is you could give people a break between treatments, a longer break. Minutes, hours, even days have been known if you want people to forget about something. The second option is counterbalancing, which means if you only have 2 treatments, we would do exactly what Jung was just suggesting. We have half of the people do the first treatment first and then the second one, and the other half does the second treatment first and then the first one, right? So switching the order with 2 treatments is easy, right? Half and half. But remember that now each measurement for statistical purposes, you've again half the number of your users, the number of your data points for each statistical measure. So it becomes harder to show significance. So you may need more users so that you can fill each possible order of treatments with enough users to get enough data points to be able to do statistical analysis on it with some level of power. So basically what we're saying here, this is O of n faculty, right? You know, with 3 devices, you already need 6 treatments, right? And so on. So this explodes quickly, right? If you do that. That's why there is the trick of a Latin square. A Latin square only grows in the number of orders that you have to go through on the order of O of n with the number of different treatments you have to cover. Let me show you a Latin square. It basically means that each condition, let's say we have A, B, C, D, E, F, 6 conditions. You can see here in this Latin square, each condition appears actually once at each position, right? A is once at the first position, once on the third position, once the 5th, over here, here, and here. Also, each condition actually precedes each other condition once, and it follows each other condition once. Also given if you look at that square. So it's a nice option. It's not quite as good as doing a full-blown, all orders covered, but at least we've removed most of the things that could lead to a biasing because of learning fatigue or other order effects. Another option is you can just randomize. Right, so you could say I randomly assign treatments to participants, and that prevents a systematic bias, of course, but it's not the same as counterbalancing. Especially with small numbers, you might fall into something similar to the Latin square where you're not covering all the combinations. Could even be worse than a Latin square because you may just randomly miss certain options there. Okay, so that's for addressing ordering issues. Now, let's say you've got your data, you've run your experiment, you've measured your things. What do we need to do with the data? Well, you need to do statistical analysis. You do that using test methods that have been well defined in the literature. There's lots of stuff out there. To the right here, we're showing a book, Quantifying the User Experience, which is actually practical statistics for user research. So it couldn't be more relevant to this case here. And some of the methods that you will come across a lot is like students' t-test, or ANOVA, the analysis of variance, which is very, very common and one of the simplest one to do. Basically, just looking at whether those 2 blobs, of your distributions overlap too much, or whether they are significantly apart from each other. The Wilcoxon or Mann-Whitney rank sum tests, or the chi-square tests. Which one you pick depends on all kinds of issues. How many variables you have, whether they are continuous values or discrete values, or what the assumed distribution of these values is. Are they normally distributed, or maybe they have a Poisson distribution or something else? Or are they equally distributed even? And also what kind of result you're looking for. Because you could just be looking for a yes or no, but you could also be looking for actually being able to claim a certain size of the differences, or be able to give a confidence with which your estimate is correct. So, there are lots of different aspects here that influence this choice. For example, discrete versus continuous. If you have touchpad versus mouse, these are clearly two separate values. There's nothing that is like in between touchpad and mouse, right? But there are other values, which like execution time, for example, is a continuous value, whereas a number of efforts that you failed is going to be an ordinal value. They have order. Touchpad versus mouse doesn't even have an order. It's not like touchpad is more or less than mouse, but your number of failed trials could be 1, 2, 3, 4, 5. So they're discrete values, but they have an order. So there's all kinds of different things you need to look at here. And that really requires you reading up in a book or taking our current topics in HCI class, where we talk about this in much more detail. Next up, making your evaluation valid and robust and reliable. Validity really means how accurate is your result. And there are two things that are unfortunately often working against each other. One is internal validity, which basically just means, is your experiment inside, robust? Have you nailed down all the variables except for one and only varied this one at a time and shown that that actually is the cause of the change in your dependent variables? This is easiest to do with heavily controlled experiments under artificial lab conditions. The problem with these is that these are the least meaningful for the real world, because the results really only hold under the particular, somewhat artificial conditions of your lab study. So the more you nail down everything and make it sort of, controlled, the less your results will be able to be generalized to other populations, user populations, or other environments or settings. So on the other hand, if you go a little more loose and use, you do a study in the field at the user's workplace with phone interruptions and so on, it's more ecologically valid, externally valid, but it tends to suffer in internal reliability because, one experiment setting, somebody was interrupted by a phone call. So that doesn't make it directly as comparable with when he didn't get interrupted. Secondly, reliability. How consistent or stable is your result? Of course, that basically means, can your experiment be replicated by other research teams in other locations? Did you give enough information about your procedure? Did you avoid any bias through your experimenters or any influence of the technology that was used in the experiment? There's lots of situations in which you can introduce these kinds of bias. And again, the literature tells you about these things in more detail. And I should say that these issues of a valid and reliable evaluation don't just apply to controlled experiments. They apply to all kinds of experiments that you report as part of your scientific work. Now, I mentioned briefly on the overview tree that there are other things you can do, such as questionnaires and personal interviews, and these can also always be used to supplement a study that you ran, of whether it's a controlled study or whether it's a qualitative one. We're done with the controlled lab experiments now. E10 is closed. We've gone through our tree ones now, right? I'm zooming out a bit here in the last couple of minutes. Other things you can do is, after you completed a project, you can have, you can look at the bug reports people file via email to the maker of a software, or you can talk to the people who are manning the hotlines of a software that was just released. And I can guarantee you they will hear about most of the usability issues people have, because if they don't get along anymore, they call the hotline, right? Or send in a chat message or whatever it is that they use. It's also helpful to do retrospective interviews and questionnaires. So after a project is done and a software is out in the field, you can still go out and talk to people and ask them how the system was picked up in practice, or observe them in practice. This is always something I can recommend, both talking to people and observing them to see what they do without, their own reflection on it clouding their perception of what they actually do. But then also talking to them to understand why they do what they're doing. So last thing I want to talk about here is how to deal with users. Whenever we do these tests, whenever we do these studies where we involve end users, we have to be aware that this can be very uncomfortable for the participant. Imagine this setting. You are called in as the usability designer and head of the design team to develop a new office software for a large corporation. So you go in and you have your first prototype and you test it with some users. And the users happen to be, you know, the secretaries and administrators working in the front offices of the corporation. You set them down in front of your prototype. You ask them to do a task like filing a report or something, and you observe them. You film them, you record their audio, you tell them, you ask them to tell you any problems they have. And that's happening. Of course, these people will feel like they're being tested because they're not used to being software testers. They think that they are being the ones that are being tested. So they'll be under pressure to perform. They'll make maybe even more mistakes than if nobody was watching over their shoulders. A lot of people say, well, if anybody's looking over my shoulder, I start making mistakes all the time, right? They might develop competitive thinking. Oh, but I didn't do as well as my colleague over there, so that's a problem. So you have to be aware of this. So what you have to do is you have to treat your participants with a lot of respect and empathy for this at all times. Otherwise, your results are just going to be useless. And maybe even worse, you might be ruining something in that company that you're going into. So the key thing to communicate is before, during, and after the test, that you're not testing them, you're testing the system. And they are helping you to find problems, right? They are testers. They are not subjects. They are not participants. They are not being tested. They are testers themselves to unveil problems with the software. One side thing of this is you don't want to waste people's time. I often see a student setting up an experiment for their thesis project. And then when somebody comes in to test it for them, they say, okay, great that you're here. So now let me write down all the details about your person and please, you know, install the software on your computer and give me 5 minutes while I'm setting up the experiment. And so that's all wasting the user's time, right? You don't want to do that. You want to run pilot tests before to debug your actual test. And you want to make sure that you have everything ready when the users arrive. Also make sure that the users feel comfortable. Make sure that they understand that the system is being tested, not them. Confirm to them that it's very likely that the system, the prototype they're testing, will still have bugs and that they are here to find these. So when they struggle with something, that's a good thing because that means the system isn't ready yet. It's not their fault, it's the system's fault. And also, of course, you know, make sure that they understand that if they still feel uncomfortable, they can always stop at any time. And you're not gonna, it's not gonna be any hard feelings about that. You also want to guarantee privacy, right? For example, any individual test results need to be handled as private data that is only shared with you, maybe your colleague that is helping you evaluate and analyze the results, but it's not going to go outside your team. It's certainly not going to end up as videos on YouTube or as a report on the desk of the boss who is running the company. And of course, while, you know, somebody is asked to test the software and show how fast they can enter forms, you're not having the boss peek over their shoulder and see how fast they do, right? That's not the idea. Right? You also need to inform people about what's being recorded, how it's being recorded, what happens to that data, and any other questions they might have. But be careful not to bias people, right? I often see people who are like students who are developing a new software tool here. They will go to a user and say, hey, I wrote a new tool to enter text into a computer. So I would like you to run this test. Here's boring old Microsoft Word. And here's my awesome tool that I've written for the last 6 months of my life. And I would like you to see which one you like better. That's not an unbiased way to ask people to compare these tools. So you need to be careful not to bias people. And only use people who are volunteering to do the test And we guarantee that and document that using what's called consent forms that tell the user what you're going to do with the data, and that in which the user confirms that they're doing this test voluntarily. During the test, don't waste the user's time. Don't let them complete unnecessary tasks. If you're just interested in the printing function of your software, don't have them type in a one-word document first that they need to print. Guarantee privacy, continue. Don't let the boss or others watch, obviously, and make sure they continue to be comfortable. This means that it's often a good idea to present tasks one by one, not to throw a big, huge task at them that they get overloaded with, but give them the tasks one at a time. Make the for early tasks simple ones so that they feel comfortable that they can succeed in the tasks. Create a relaxed atmosphere, provide some breaks, provide some coffee, some snacks. And if they make a mistake, don't face palm right in front of them. Never show them that you are unsatisfied with what the user is doing. Turn off your cell phone, of course, avoid interruptions, and abort the test if you feel that people are becoming too uncomfortable. And after the test, it's similar. Still make sure people are comfortable. So repeat to them that they helped you find ways to improve the system. Inform them. Now you can answer any questions that they might have had that would have changed the experiment if you'd answered them before the test, and continue to guarantee privacy. You don't publish results that can be associated with specific individuals. And outside your own group, you would show any video recordings, for example, only with written consent from your users. All right, that wraps it up for today. We've covered when, why, where, and what we test. We've talked about lab versus field studies and participatory design. We've looked at all these different techniques here, such as evaluating without users and evaluating with users, qualitative and quantitative measures. A lot of focus here on controlled experiments because this is stuff we often do in our classes. And we've wrapped up with some hints on how to work with the people that help you test your prototypes. Thank you very much. And next time we will meet will be a new year. We will be talking about GOM-STEM as an interesting mathematical model to actually evaluate systems without sometimes even having to build them. It's quite fascinating, really. Until then, I wish you Merry Christmas and a Happy New Year, and enjoy your break and your vacation. And I hope to see you all back safe and healthy next year for the continuation of our classes. Bye, everybody. And Hyon, we'll stay online if you want to ask a question.
This content was provided by RWTH Aachen University.